Thanks for tuning in to Stay Sharp with Razorleaf, your secret weapon for all things digital and products and manufacturing. This episode looks at another angle of AI, which is the importance of the quality of data that an AI algorithm sits upon. How do you know you have the right foundation for your AI requests? Jonathan and Jen unpack some of the key things to consider when it comes to AI and data quality. What are the things you need to think about? How reliable are the outputs of your AI tool? How accurate is the data going into the system? What if your data includes data from other systems from integration? How do you know what to look for? Let's listen in. Welcome back, everybody, to Stay Sharp, a podcast about all things digital related to products and manufacturing. I am Jen Ferello, and I'm joined today by my colleague, Jonathan Scott.
I know everybody's surprised to see me, but hey, everybody.
Again. In past episodes, we've started digging into AI, artificial intelligence, augmented intelligence, accelerated intelligence, and its role in product development, kind of how it does what it does. And one of the last things that we talked about in our last podcast on AI was the importance of a good foundation. Matter of fact, I would arguably say it's the single most critical piece of AI, and that is the data. But I wanted to throw that over to you, Jonathan. Is that the most important? I mean, we've learned about how important it is to train a model, to give it the tools to recognize patterns, process analytically. Aren't those arguably just as important?
Maybe they are. And, not being an AI researcher, I probably don't have the most informed opinion on the topic, but I'm just going to speak logically as an engineer and somebody who's, worked with computers and done coding and that kind of thing, that I think the first step has to be one of the most important. If you get the beginning of the process wrong and having the right data to use to train a model, to validate a model, that kind of thing, having the right data is one of the first steps. And if you get the first step wrong, you're probably on the wrong path already. So I do think it's one of the most important ones. I'm not going to do a very good job at handicapping how these things all are relative to each other, but it's certainly worth talking about because I think in this digital manufacturing and product digitalization space, that's the thing that we can work on now, today, right? And that's the thing that anybody can work on. So I think it is one of the most important and it's one of the most pragmatic. So it's worth digging into. So I'm glad we're talking about the topic.
Well, and I think you brought up a very good point. It's the first step in AI, right? Is basically, and we talked about that a little bit on our podcast and Under the Covers of AI. What is it doing? Is the first thing it's doing is collecting data. And the accuracy, the precision of that data is critical to being able to train it, to be able to recognize patterns, to be able to have it make decisions. I mean, if it's bad data, it's the old adage, garbage in, garbage out.
Exactly.
It's got to be good quality data.
Or
all you're going to be doing is making bad decisions really quickly.
Right. And quality can mean a lot of different things, right? So I think in terms of what we mean by data quality on this episode and where we're going with it, it can be kind of comprehensive. I don't think we're just talking about, is the data complete? Does the data have errors? That kind of thing. But I think we're also talking about things like relevance. I'll give an example of what I mean. If you were going to train an AI model and you wanted it to, guess the next kind of design you wanted to make, and your company used to be made up of, 5 different divisions that made nuts and bolts, made aircraft, made cars, made ships, made all those things. And then today, your business is just making aircraft. Would it make sense to include the nut and bolt design data from 30 years ago in the data set you use to train AI? I don't know. There are probably arguments where maybe it does. But I think thinking about what's the relevance of the data to what you're trying to do, and maybe I could give a more obtuse example that makes it clearer. Should you include your financial data? I don't know. If it's totally irrelevant and it's like people's paychecks, probably not.
That's true.
Is that data?
But if it's supplier data, and
maybe so,
cost and things like that, then it may.
But all I'm trying to add by bringing that example up is when we say quality of the data, I don't think we're just talking about, are the database fields filled in? Are they the right data type? That kind of data quality. We're talking about that overall picture of what is the right data to use, and is it in good shape? Is it appropriate to use for AI?
Well, and I think not just is it accurate and precise and relevant, is it reliable?
Yeah.
I mean, is it something that you like, it's predictable, it's reoccurring, it is like, yes, this is something that makes sense for you to understand the process and understand the data itself.
That's reliable is a great word for that, right? It makes me think of another example where just pay attention, think about it. We do a lot of work or have done a lot of work in the past where people are bringing non-digital data into the digital world to use it. So, concrete example, scanning drawings, 2D drawings that were made on Mylar years ago. You'd like to bring those forward. Well, you can bring them forward as just a picture, just an image, or you can try to bring that forward with some intelligence and do like optical character recognition, OCR, on the bits and pixels that you see on the screen to get more information out of it. Well, then you could use that to start to be real data that you train something on. Like, oh, well, every time I have this bracket, I have a high tolerance of this hole on it, that kind of thing. Well, you'd know that if you could recognize all those pixels to determine that that's a tolerance symbol and here's what it means and when it's this kind of part. And you recognize from the title of it that it is a bracket or whatever it might be. But if there's too much noise when you do that conversion process, maybe that data is not reliable for making those kinds of inferences you just described. So reliability is another piece of that data quality. Can you trust it? Have you done some processing or steps in the middle that mean the data is not good or it's partly good or whatever it might be?
That's true. Have you changed it in translation, as it
Exactly.
were?
Exactly.
Or the originators, like, did they always put in, like in a particular title block, did they always put in the right part number, the right format, et cetera? So how reliable was your input?
Yeah.
And when we were talking about, I want to come back to, like, you mentioned relevance and making sure the data is relevant. You have to be really careful there too, right? Because that's where eliminating too much can create that bias that we were talking about.
Exactly. I think that's absolutely true, right? And so that's why I wanted to be clear at the outset about what we mean by quality, right? Is it may not be traditionally what you think of as quality, but it's all aspects of, is this the right data to do what you're trying to do? And that could go both directions. That's a sword that cuts both ways potentially. I've eliminated data that I think is not relevant, is not reliable, is not helpful, is not good enough quality, whatever it might be. But in doing so, did I generate a bias because I left out something that was important?
Right,
Vice
that you didn't
versa.
even realize
Right, you
was
didn't even
important.
realize. Exactly.
And that's kind of what we were, when we were talking about how quickly AI can process data and find patterns that even we do not see. Like, maybe that was important data.
Exactly. So I think that's, I hope people listening to the podcast, one of the takeaways they have today is that I don't think we mean to be prescriptive by what we're talking about today, so much as informative. Like,
Right.
think about these issues, not that we're saying you have to do it X or Y way,
Right.
particularly in areas where I think the state of the art of AI is advancing. And they're going to have answers for us. They're going to be able to tell us best practices in a year, 2 years, 5 years, that kind of thing. But at least be thinking about it today. Do your best to collect the data that you might need and do what you can to improve its quality. Beyond that, wait, stay tuned. Stay tuned till the AI folks are telling us exactly how to use it.
Right. But I mean, again, be aware of these things though.
Right.
Be on the watch out, be thinking about them in the background. Because it's, again, getting back to the importance of, like, why is data quality so important? It's because this is the data that AI is helping you make decisions on. So, an obvious, like, if you're using AI to increase operational efficiency, you have to make sure that the data is good because you're going to be reducing the number of errors that process is making if it's making decisions based on good data.
That's right. That's right. And I think the thing that you can consider today when you're thinking about data quality is how accurately are you representing the real world, the information that you know to be true? Where are you making shortcuts? And this is, again, not to be prescriptive because every situation is different and you have to think about that context to make these decisions. But we have computer tools, digital tools today that will let us capture more details than we have time to capture, right? So You think about one industry and what they capture about, like maybe using photogrammetry and metrology and measurements of their parts. And they can get it down to such a small level with their specialized tools because they have to take that same concept and move it over to another industry where maybe their parts are much larger and they don't care about that accuracy. Well, we know the computing power is there because of industry A, but we know that the relevance is not there because of industry B. But what it tells you is that the world of possibilities, what you could do, is much wider than the world of practical capabilities, what you need to do, what you should do. But you have to think about it in this data quality context to decide, what do I grab? What do I hold on to? What do I keep? Because it might be useful to training these models.
And that's what I was I'm glad that you said it because it might be useful because just because you don't need it now
Right.
doesn't mean that we won't progress to the point that it does have value.
Mhm.
All of that data does have value because AI has uncovered that, if you will.
That's right. And that's what AI can be very good at, is finding the patterns that we don't see. So back to the bracket example, maybe there is a relationship between like the cost of the part and the tolerance of the hole. I use that one because I understand that one. Yeah, there usually is some relationship there, right? I learned about that one very early in my engineering career, is stop putting the tight tolerance on the part that doesn't need it because it makes it very expensive. Great. I know that relationship, but what are the other relationships I don't know about? And if I didn't capture the material properties in my part definition in a way that it was in the data set so that the quality of the data was there around material, if I didn't capture that, would I ever see the relationship between it and lead time or failure rate or whatever it might be that perhaps AI will find? But I couldn't see it.
And it's interesting when you present it that way, it makes me think of all of the silos of information that we have in a digital product process,
Right.
right? Where you've got design that's just only focusing on the design, and then you take it to manufacture or simulation, and they're like, oh no, that's going to be really expensive to manufacture. So go back and redesign that. Well, if you've got AI processing all of that information, it can start making those connections. So and making your designer smarter or your CAD system smarter so that you're aware of those things and you can eliminate that out of the process altogether.
So I
Or
love the word connection there, right? That AI could help you start making those connections. And I'll say potentially, if if you had already made those connections in the data, or not necessarily those discrete observations, but the data was connected enough for AI to find that pattern. And this is where I think data quality gets into the space of work that we do regularly, right? We do a lot of work around integrations and putting pieces of data together across multiple systems. And if you didn't have a way of understanding the relationship between the digital product data and the digital manufacturing data about it, and maybe the quality or the sourcing or all those different areas, silos, like you
Mhm.
mentioned, if you didn't have connections in the data sets to use that to train the I don't see how AI could have ever come up with that if it didn't see the data connections, if it didn't understand them.
Right. If it didn't have that umbrella view, a 10,000 feet view.
Yeah, exactly. Right. And that's back to data quality. Do you have data sets that really are sets of related information? Or do you have just little pockets that aren't connected, aren't related, and the AI will never figure out how they go together? Right.
Well, and it really underscores the importance not of just the initial data, but all of the what's the word I'm looking for? Derivative data
Right.
and testing and validating. That is all still accurate and precise and stable and scalable and reproducible, et cetera. So that all along the process, AI can make the connections to be able to make the decisions. Because again, that foundational level, if the data is bad at any point, you're all you're doing with AI is making bad decisions faster. Now, I don't think in the entrepreneurial world, they're all talking about like, oh, you want to fail fast. I don't think that's what they're talking about.
Yeah. No, I agree. You're not talking about getting tons and tons of failures, so you're constantly failing. That doesn't help. But if you're going to fail, finding it fast, I like that interpretation better
Yes.
than just
Then
failing
fail
all the
fast.
time.
Well, and I think a big part of the importance of this data integrity to AI is because you're looking to build user trust
Right.
and user confidence. It's creating a transparency so that users can trust decisions or the processes that AI is creating.
Absolutely. I think that I don't know how the world is going to look in the future related to AI, but I can imagine one thing that would at least be helpful to me when I think about how could I use AI in a couple of years related to that topic of transparency. I don't expect we'll always understand how AI gets an answer for us, right? That's part of the beauty of it is it sees patterns that we don't. It comes
Mhm.
back with answers that we didn't expect, and that's great and that's helpful. But if those models, the training models, the validation models, or anything about AI can explain something to us, can show us where it came from, can at least point to the data set that it learned from, perhaps we get a little bit of an insight into how it came to the answer for us. And that transparency could really build trust. It reminds me of a theme that one of our colleagues used, Jen Herron over at Action Engineering. She at one of her events, one of her company's events a couple of years ago, the theme was trust digital, and it was talking about the model-based enterprise and how you really can't have an effective enterprise if people aren't trusting the data that they share across each other. Same thing here with AI. Trust the results. You can't trust the results, and it's hard to use the results if you don't trust them, if there's not some kind of transparency, if you don't know where it came from. And I think that's an important piece of this. I don't know what the answer is going to be, but I agree with you. It's important to how you're going to use the data to be able to trust it. And that's likely to come from, well, did it come from a good data set originally? Do I believe how it got trained? Is it trustworthy?
Well, and is it, I mean, a large part of that, creating that trust is the same way you create trust in any capacity, right? It is over time
Right.
and and with performance. Like, so, okay, I gave it a little bit of responsibility and it did that well. And it continued to do that well. And yes, it led me in some directions that were positive. So now I'm going to give it a little bit more and a little bit more. And I think you're right. It's that it allows it to be scalable over time, but it has to be again, it's built on that good data, that foundation of good data. Because if it's bad data, it's not going to be trustworthy decision making or results or things like that. So you're not going to have that trust.
And you could get to even the reverse situation, right? So I'll give you another practical example that I've seen is we talk some about the character of the data when we do integration work,
Right.
right? And understanding how data behaves, like say like a bill of material. A bill
Hmm.
of material is a set of records with a hierarchy, parent-child kind of relationships, that sort of thing. And there's a lot to it, right? I don't want to get all into those weeds today, but when you know that that's how a bill of material behaves, you have to treat it a certain way to take care of it, to make sure you haven't corrupted the data as you move it around, as you integrate it, as you do whatever you're going to do with that data. Well, when I go into an opportunity with a customer to look at their data or talk about their data, and I see that they've been misunderstanding data, right? That maybe the IT team didn't really understand how that bill of material worked. And maybe they moved it across systems in a way that made some bad assumptions and it led to data on the target end that wasn't quite right, wasn't entirely wrong, kind of suited
Right.
their purpose, but it wasn't quite right. That makes me call into question what they're doing with that data on the other end. Could the result and the outcome be flawed based on a misunderstanding of the data? And if I recognize that it is, I'm going to get my hand up and point that out and highlight, hey guys, you could be using bad information here because of how you treated the data, handled the data, whatever it might be. So it's the flip side of that coin that if you in the future are looking at the results from your AI, but you dig into the data set to train it, or maybe being used to train it on an ongoing
Hmm.
basis, and you see a flaw in that data set, where did the trust go, right? For me, the trust goes through the floor. Suddenly I'm like,
Right.
wait a minute, whoa, it might have been giving me good answers for the last couple of years, but when's it going to give me a whopper of a bad one? Because I know it's looking at bad data. So
Right.
that trust can go two ways.
Well, and it's interesting. So you've jumped ahead a bit to not just the quality of the data, but our understanding of it.
Right.
Correct. So
Absolutely.
let me rein you back in a little bit.
Please do. You need to regularly. So
we will,
absolutely.
we will get to that point. We will get to that point. But I want to I want to stress the point what we've been talking about, the foundation, making sure the data is good, making sure it giving you responsible and reproducible, scalable answers. One of the things you have to be careful about with data and your AI foundation, if you will, is that you are regularly maintaining that data and updating that data because, as we know, data changes over time, right? And it's not like, I know, like, for instance, ChatGPT, now 2 years old, right? So we're going to have to, obviously, that's going to need to be refreshed because I'm guessing there has been some level of information
Have things changed?
accumulation
Yeah.
in the last 2 years, maybe. Things have slowed down a bit.
It's right. You're exactly right that we have to think about keeping up with what we're training the model with, the most current information, that sort of thing. And this, to me, is one of the tricky parts of AI is if you're constantly updating it, you're constantly validating it, you're constantly checking it. What are you feeding it? Are you sure that it's the same kind of data? Better data? Worse data? I don't know. This is where my head starts to hurt related to AI. But so when it does, I come back to what are the fundamentals that I think I can trust. I feel like I can trust the fact that constantly paying attention to the quality of the data you feed it, that's permanent, right? That's
Right.
not going to change.
And making sure that you're feeding it regularly, right? You don't feed your pets or your children once, because they won't continue to grow very much. They won't be very useful moving forward. But also not just feeding it and maintaining it, but also making sure that it's secure.
Yeah. That's a big one going forward, right? Like
make sure you're the one feeding it.
Right. And not someone feeding it, a bad actor, feeding with bad information, or just unintentionally not good information. All of those things, that comes back to that trust issue. I think we have to pay attention to all of those. What influences the quality of our data? Just our work or information we get from other places?
Well, and not only that, but like also regulatory compliance, right? So is the data within specific, and this obviously this doesn't apply to every industry, but certainly aerospace, automotive, medical device. And I'm sure heavy machinery. That actually probably does apply to most industries, just in different ways.
Yeah.
So I take that back.
You're right. I think it does. It applies in different ways in different places, but you do have to pay attention to it. Right? What does that mean, right? If you think about regulatory compliance, what data are you not allowed to include? What data must you include? All of those come back into that quality topic.
Well, and I imagine regulatory compliance is also an area where AI can be very, very useful as far as spotting anomalies, spotting patterns, et cetera. So I think it's a space to watch. But now, if we've talked about like the quality of the data and the reproducibility, the scalability, the trust, we've built that up. We're continuing to maintain it, making sure it's secure. Now, I want to dig into what kind of data it is, the importance of understanding. Now you've got all of this data, understanding at a human level what sort of data that you have, because that's what's going to be used to kind of train your models, right? As your understanding of that data.
I think that's right. And it may be that then the machine's understanding of that data is also used, but it's could be a house of cards, right? That understanding gets built up from the data. And there's an understanding of it based on human input, based on maybe machine learning input, based on several things. But you have to pay attention to that every step along the way. You have to validate it every step along the way. If you're making connections in the data that you didn't see, the machine saw, are those right? Do they make sense? Like once you've seen what the machine sees, like, do you agree or do you disagree? I think all of that is important. And it comes back to that notion of understanding the character of the data. Do you understand the data or do you misunderstand the data? And that's tough.
Well, and that's where integrations comes in, right? That's where when you're talking about building up your understanding of the data over time and a different view of that data. So the design data might be perfectly fine, but what you're doing like when you go into bill of materials, et cetera, like there are different things that you need to be aware of that the machine, if you don't teach it, is certainly not. Heck, the guy in the next department might not even be aware of.
Right.
So that's dig in a little bit for me, if you will, like the difference in where that can have an effect. We've talked a little bit around that, the understanding the character of your data.
Yeah, I think, like you said, one department may look at it differently from another department. And if you can harness that to increase the fidelity of how you model the data, then you've got richer data, you've got its character better defined than if you don't, than if you just look at it from one angle. Like that bill of material example I used earlier. Perhaps one department just looks at it as, look, I need to know the total quantity of all the parts that go into it. I really don't care that there's some sort of hierarchy to it where it's a grandparent, then a parent, then a child, and multiple levels and multiplication that goes on of, if I got a quantity of a subassembly, then I multiply the part children. Some people may not care about that. They just want to know the total number of bolts in that helicopter. Okay. But other people need to know step by step what that buildup looks like. If you understand that that's how, what the nature of that data is, then you can capture it in a way that can suit both needs. But if you didn't understand that, you may simplify your understanding of it to take a shortcut, to be easier. That then creates a problem for the person that needs that detail, needs to understand that nuance. And that's, I don't know if that's a great example of it, but I think it points to this idea of, if you have multiple perspectives on the nature of this data that you care about, you can get a high enough fidelity model that works for everyone. You have to balance that with the complexity, right? So the people who need to see it in a simple way, maybe you need to present the data to them in that simple way, because otherwise you overwhelm them with the complexity and fidelity of your model. So it's tricky, but I think that's what you're talking about, right?
Yeah, I mean, it is basically, it's different, almost different views into the same data, right?
Right.
Because even your simple example, I just needed to know the total number of parts. Well, what if you get an overloaded bomb, 150% bomb? Like, okay, now you think there's 300 parts in there. No, those were actually alternatives. There's really only 150.
That's right. Those were alternates. Those were spares, but you didn't know that because you didn't understand that nuance of the data. And so you had a misunderstanding as a result.
Right. And again, that's something that, as we're moving forward with AI, that goes to
Quality of the
understanding.
data?
Yeah, quality.
Yeah.
I mean, not just quality, but like your understanding of what data you have. So
Exactly.
it's actually it's the quality of the data plus the quality of your understanding.
Yes. Yep. Because it goes back to, how do you train the AI? And that's the whole point we're trying to make here, is the results that you're going to get out of the backside relate to the inputs at the beginning. And the input at the beginning is the data. What is the quality of it and the quality of your understanding of it? Because to your point, you go set that model loose and say, hey, here's what you should understand from the data set. If you understood it wrong, the AI will understand it wrong.
That's a good point, particularly when you have so many people building up from that foundation. There are different perspectives. Like, well, no, I got it right for you, but that's not right for the other guy, who's not right for the other girl.
Before we wrap up, Jen, I want to come back to the point I made earlier about us not being prescriptive, right? Because I hope it doesn't sound like that. Except I do want to offer one prescription, right? I want to offer one thing, which is pay attention to the quality of the data. I mean, that's the theme of the episode we're on here. I think that is important. Think carefully about how you curate this data, how you manage it and maintain it, how you integrate it, how you create derivative works, to your point about derivative outputs. Think about all of that, because someone is going to come along in your organization sometime soon and say, I want to use that for a model. I want to use it for an AI model. I want to train on it, right? So prepare for that. Prepare for that now by thinking about the quality of your data when you're doing a data migration across systems, when you're doing an integration. Now is the time to think about that. Don't think about it later when you don't have time to influence it and control it. That is the one prescriptive thing I want to make sure I'm saying today.
Well, and I think that's, not only is that really, really good advice, but it's almost the only thing that we can be focusing on right now, because even though AI has been around for so long, like, it is still very early on in the process and what we can use it for. And this is the area that we can completely control. Well, not completely control, but like heavily influence.
Right.
And to your point, like, the longer you wait to get that right,
the less runway you have to solve it.
And the more questionable your foundation is to begin with.
Right.
So if you're not already paying attention to that, then, the chances are, we'll just pay attention now.
Right. Well, and connect the dots.
If you haven't been yet, now is the time to start.
Yeah. Well, and connect the dots, right? I mean, why do we even care about AI? Why are we talking about it today? Why is this worth us mentioning in the podcast? It's because we all see it and go, wow, that's got tremendous potential. I don't know quite how it's going to get used. Maybe my company's going to be a first mover. We're going to make great use out of it. Maybe my company's not, and we're going to be a fast follower. Maybe we're going to be a laggard. I don't know. But something's coming. Try to get ready because that gives you some advantage. You don't want to be caught flat-footed when your competitor is that first mover. And you say, we could have done something. We could have caught up. We could have been right behind them. But we weren't. Our data wasn't ready. We didn't, we ignored the signs. We didn't get ready. And I think that's what we're trying to say is just get ready. Do what you can to get ready.
Yeah, recognize the importance at every step of the way of having good quality data and building an understanding of that. As a matter of fact, as we wrap up, that's one thing I want to suggest that we revisit in a future podcast is I really want to dig into the application when we're talking about the character of the data and understanding the data that you do have. I want to bring that back to our listeners that I'm assuming are primarily in the PLM space, or at least using a lot of those tools, the digital manufacturing space. So I want to bring that back into some very practical applications that we have seen and how that can be, bring this all, make it real.
Yes.
So
yeah, more than just that bill of material example, right? Because there's tons of those examples we should dig into.
Right. And we don't have the time right now. Thank you for kind of catching me on that. I know it's usually my job, but thank you for catching me on that. We don't have the time to dig into it right now, except to say, let's put a pin in it and revisit that in the future. Okay. So, Jonathan, thank you again for joining me today.
Absolutely.
Very good discussion.
Another fun one.
Another fun one. And I want to encourage our listeners to reach out and tell us what you think. Is there something that we missed here? Is there something more that you want us to talk about in this particular space? Particularly when, if we're going to be talking about the character of your data and understanding the data that you have from different perspectives. So reach out to us on social media. You can find our podcast everywhere you can find podcasts these days. But be part of the conversation. It's much more fun than just Jonathan and I talking all the time. We'd like to hear from you. Anyway, until next time, stay sharp.
Thanks, everybody.
Thank you for being here and listening to this episode of Stay Sharp with Razorleaf. If you have any questions about data quality and AI, we'd love to have that conversation. So just leave a comment on our post or send an email to podcast@razorleaf.com. We appreciate all the feedback we get from our listeners, so please be sure to send us a note. And also, please subscribe to our podcast on your favorite podcast platform or our YouTube channel. Until next time, stay sharp.